stop at this slide. And we talked about something about perfect substitute. So panel A and perfect complements, panel B. And something in between, which we call it imperfect substitutes. So panel C. And panel A, now I give you two examples. The first one, we've gone through this one. So if something on the X and Y representing, say, $50 coins and $100 bill. So what about the relationship between these two goods? If we do not care about coins or bills, we just care about the total amount of the money, then say two $50 coins is actually the same, or just give, I should say, provide us the same level of utility as a $100 bill, because they provide us, or they give us $100 money, right? So the utility should be a straight line, look like this. And if this is 2 and this 4, we have another utility levels, or we call them as indifference curves, right? So the farther the indifference curves from the origin, the better we are, right? We will be better off. We prefer this one to this one to this one, this one, this one, right? So it's a 2 to 1. The ratio is 2 to 1. And we may put this kind of indifference curve if we want to if we want to try to adopt or use or employ some utility function to describe this relationship or this kind of preferences. What should we do? We may use the, say, utility equals something on X, and I should say, so something on X and something on Y. Now X is $50 coins and Y is $100 bill. So the coefficient should be 1 to 2 or 2 to 1? 1 to 2 or 2 to 1. X means how many coins of $50 bill, $50 coins, and how many $100 bills. This is the number of the bill of the coins. So what should you put the coefficient? Should be 1 to 2 or 2 to 1? What about, so 2, 0 should give us the same result as 0, 1. Is that right? So it should be 2 to 1. If it is 2 to 1, then it will be 4 and it will be 1. Is that right? Alright, so it should be 1 to 2. The reason is that per unit of y give us a $100 utility or $100 money value. The monetary value of the number of y for each unit of y equals $100, right? So the monetary value should be 100, and the monetary value of x should be 50. So it is 1 to 2. We may use this, or we may say u prime or v equals 50x plus 100y. These two functions give us two different forms of utility function, but they are capturing the same preference because they are positive monotonic transformation of each other. Is that right? So this function multiplied by 50 would be this one. Is that clear? So you need to figure out x and y denote the number of $50 coin and $100 bill. Is that clear? So the coefficients should be 1 to 2. Any question about the first example?
我想要问说，就是像第一题，它是50块的钱跟100块的那个钞票，那照理来说不是等于两个 coin 会等于一个 bill， 那为什么不是？
Yeah, two $50 coin provides the same utility level with $100 bill, right? So the coefficient means the value this kind of good can provide us, right? So the value of x and y should be 50 and 100. It is 1 to 2. Is that clear? X and y represent the number, the units, how many units of the coins and the bills. And the coefficient should be the value these two types of goods can provide us. Is that clear? Sure. Because two $50 coins gives us how many money? How much money? $100, right? And $100 bill gives us $100 bill, $100 monetary value. So the value should be 50 and $100, right? And we may divide them by 50, so it's 1 to 2. The value of the bill is twice as the value of the coin. Is that clear?
What the value means? The value of coin?
Utility value. One, think. Do you like some snacks like you like this or not? Okay. Otherwise, let me give you another example if you do not like white. Say Oreo. Do you like Oreo? The cake. Okay. So there are some small pack and large pack. So for X, if it is small pack, and Y large. And in one large pack, there are 5 small. Let's just assume this, okay? So if you got one large pack, which means it is the same as you have 5 small pack, okay? So what about if X is X small and Y is large? So it will be 1, 2, 3, 4, 5, 1. Is that right? Then what would be the utility? It should be 1, 2, 5. Because per large pack provides us 5 times utility as the small one provides, right? And if we change, we put large on X and small on Y, it would be like this. The graph looks like this. And this time it would be 5 to 1. Okay? What do you mean U1 and U2? Okay, the marginal utility, in the first case, if it is small, large, then MU1 would be 1, and MU2 would be 5. Which means an extra unit of small pack Oreo provides us 1 unit of utility. And per unit of the large pack, give us a 5 unit of utility. So it is the marginal utility. How to compute 1 and 5? You just partial U, partial X, right? Partial U, partial Y. Partial U, partial X gives us 1, partial U, partial Y gives us 5. Is that clear? So the logic is actually consistent, be it graph, math, or intuition, the interpretation. The intuitive interpretation, okay? So I hope you may learn these 3 kind of things at the same time. So everyone happy with this result? All right, let's think something simpler. If we have blue pens and black pens, and if one does not care about the color of the pen, one just cares about how the function of the pen, which means he or she can write using the pen. Okay? So either blue or black pens provides the same utility to her or to him. It depends on, her or his utility level depends on the number of the pen. How many pens he or she has. That's the point, okay? So in this case, we just put a graph x and y, and if x is blue, y is black, then it should be 1 to 1. Alright? I don't care the color of the pen. I care the function of the pen. I can use the pen to write. Okay? So the indifference curve is straight line, but the slope would be -1. And the utility, in this case, utility would be 1x plus 1y. Of course, you make it can be 100 and 100. No matter it's 1, 1, 2, 2, 5, 5. The same thing, right? Because the utility function, it is not unique. Any kind of positive monotone transformation can provide us or can help us to capture the preference. Then the utility function works. Okay? So whenever a utility function can help us to catch the nature of the preference, then we do not care about the number, the coefficients. We just care about whether this utility can help us to capture the preference. So actually 1, 1 or 100, 100, they are just monotonic transformation. Okay? So this would be 100 times of the first one. Any other question? And what do you think? If I give you x plus y squared, will it be the same thing? Would utility function v provides or help us the same function of capturing the nature of preference as u? This one is the square of this one, right? And something whose square is actually the positive monotonic transformation. Is that clear? Let me show you. All right, marginal utility of x would be 1 in the first case, and marginal utility of y would be 1. Is that right? What about partial v, partial x? It would be 2x plus y times 1. Partial v, partial y would be 2x plus y, 1. They give us the same utility level, right? The same marginal utility. We do not care about the cardinal, the absolute value of the marginal utility. We care about the ratio. The relative value of these two. Is that clear? Okay? Alright, so let me assume that all of you are good at perfect substitute. And let's go on to perfect complements. Last week I gave you the example of left shoes and right shoes. And because we care, the key thing we care about is the number of pairs of the shoes, right? So extra left shoes or extra right shoes just do not provide any further utility. We just care about how many pairs we have, how many pairs of shoes we have. That's the key point we care about. So in that case, we care about x and y, the minimum of x and y, and x is left shoe, y represents right shoe. So it's 1, 1, 2, 2, 3, 3. 45 degrees for the kinked point, okay? And so 1, 1 is similar to 1, 2 to 1, 3, or to 2, 1, 2, 3. Either for any points of these 5 can give us one pair of shoes only, right? Just one pair. And here would be 2 pairs, so it's so be it 2, 2, 3, 2, 4, 2, or 2, 2, 2, 3, 2, 4. For this kind of combinations, provides us 2 pairs of shoes only, right? So we care about the pairs. So the utility will be 1, 2, 3. And so, for example, 2, 2 provides us 2, 2, and the minimum of 2, 2 would be 2. And 3, 2, 3, 2, the minimum of 3 and 2 would be 2. Still 2, right? Okay? Is that clear? And the coefficient would be 1 to 1. Okay. And then let me give you another example. So if someone, whenever he drink coffee, he wanna some milk in the coffee. Once again, someone do not like black coffee. He or she prefers coffee with some milk. And if the perfect proportion for him or her is 5 to 1, 5 share of coffee with 1 share of milk. If he or she just insists this kind of proportion, so anything more or less than 5 to 1, we just do not think is important of bring him or her anything else. So in this case, if x is coffee and y is milk, so 1, 2, 3, 4, 5 coffee with 1 milk. Provide him or her the utility. And 6 coffee with 1 milk. She just does not need the extra unit of coffee. Okay? This would be the perfect mix, the perfect proportion for her. So 5, 1 or 10, 2, which means 2 cups of milky coffee. Okay? Then you'll see the utility or the indifference curve will look like this. It is still L-shaped indifference curve, but the kink point, the slope would be 1 over 5. Okay? And in this case, what would be the coefficient? should be 5, 1 or 1, 5. Let's think in another way, would be easier. All right, in this way, X is coffee and Y is milk. So, for a cup of coffee, the share would be 5, 1 in 1 cup. Okay? In 1 cup, it's 5, 1. So 5, 1, which means 5x is the basic input of a cup of the drink. And 1 milk is the necessary input of a cup. Is that clear? So, when X and Y is 5, 1, then this V would be 1. And if X and Y equals like 6 and 1, it would be minimum 6 over 5 and 1 over 1. So it's 1.2 and 1. The minimum would be 1. Okay? Until like 10 and 2, then 10 by 5 would be 2. 2 by 1 would be 2. It would be 2. Okay? Let me give you another example. If someone likes, for example, 老王. 老王 insists if the perfect combination for 老王 is 1 sticky tofu with 2 bites of 泡菜, pickled vegetable, or kimchi. But kimchi is Korean style of pickled vegetable, right? So 1 tofu with 2 bites of 泡菜 is perfect for 老王. Then if this is X and this is Y, X, Y should be 1 to 2, right? For a perfect combination, 1 sticky tofu provides 1 unit of this kind of thing, right? This kind of combination, and 2 bites divided by 2 provides 1 unit of the combination. Is that clear? So we may also have 2x and 1y in this case as the monotonic transformation of this one. Is that right? You just multiply this by 2, then you have this one. Is that clear? All right. Perfect substitute, perfect complements. And something in between. We usually use Hoppe-Douglas as a utility function for economists because Cope-Douglas is quite simple and very nice to use. X to the power of alpha, y to the power of beta. We call this kind of utility function as the